Okay, so welcome back to my YouTube tutorials. In this video, I'm going to take you through how to solve differential of a vector value function. So I have this question here which I would like us to explore the solution to this question. It says given r equal to x squared sine yi plus x y squared j plus z exponent 3 cos yk. Find the r. Okay, so I have solution. Now the question is asking us to find the r, but then to be able to get this, okay, you should always have it in mind that if you are working this, okay, the r is always equal to r sub x dx plus r sub y dy plus r sub z dz. Okay, and that is, it means this is differential of what? R. So this is differential, so differential of R. Okay, so it means that if this is a differential of R, that means R prime of t, okay, R prime of t will exist, okay, if it is differential, at what? T. Okay, so to be able to find the solution to this question, we are going to use the term by term approach of what? Differentiation. Meaning we are going to differentiate this term by term. Okay, so I have the question here. Says r equal to x squared sine yi plus xy squared j plus z cube cos yk. So differentiating this term by term, we are going to have the r equal to, okay, the differential of x squared sine y I plus differential of xy squared g plus the differential of z cube cos y k. So we are going to apply the product rule. When differentiating this term by term, we are going to apply the product rule. In your pre-calculus, you've learned how to differentiate a given function using the product rule. And that is what we are going to apply this. Okay, we are going to apply that to this problem. That's what it means by differentiating this term by term using the product rule. So here, if you are differentiating this with respect to x, the variable involved here is x and y. So you're going to differentiate this with respect to x and y. So the first differential using the product rule, okay, so if you are considering this, if you want to maintain this and differentiate this, we are going to have 2x sine y dx, okay, plus we keep this and differentiate this, that will be x squared. Whenever you differentiate sine, okay, it's cos, and the cos is not negative cos but rather positive. So we have cos y with respect to y, that is dy. Then we close the parentheses, I. Then we move on to the next term, which is this. The variables involved here is x and y. So mind you, our differential is going to be based on what? X and y. So we have here, we are keeping y and differentiate x. So we have, when differentiate x, it will go to 1. So we have y squared dx plus, we maintain this and differentiate the y, that will be 2xy with respect to what? Y. Okay, or g. Then let me continue from here. The next step, that will be plus this. Okay, you can see that here we have z and then y. So we are going to differentiate it with respect to these two variables. So if you am to differentiate keeping the z, we are going to have minus, so with respect to y, minus minus z cube sine y. Okay, minus z cube sine y dy. Okay, then plus, this time around I'm keeping this and differentiating this with respect to z. So that will be 3z exponent 2 cos y dz. Then you add the vector scalar, which is k, to it. So this is how to go by it. So reorganizing this, you're going to have a final answer to be the r equal to, in parentheses, we have 2x sine y dx plus x squared cos y dy I plus y squared dx plus 2xy dy og. Okay, here I can factor the minus out here, and that will be a minus in parentheses. We have z exponent 3 sine y dy, then minus 3 z squared cos y dz. Okay, cos y dz. Then we have the key here. And so please, this is the final answer to this particular problem when you are applying to the product rule. Okay, differentiating this term by term, this is what you're going to arrive at as the final answer to this particular question. So whenever you are asked to differentiate a vector value function, if you are trying to find a differential of that, okay, use this method to get it. There are other methods which could also be used to get the answer to this particular problem. Okay, so if you find this video useful, kindly subscribe to my channel, like it, share, and also do not forget to hit on the notification bell, so whenever I update my video you get a notification. Once again, thank you for watching this video. Goodbye.